Hi everyone, this is Anil. In this video, we'll talk about AZ104 last few hours of preparation. So I have my exam scheduled in like another few hours, and in this video, we'll see what preparation I'm doing in the last few hours. So let's get started. So I'm back to the learning site where I'm searching for where I have the list of modules for AZ104. So I'll go and search here, and I'll do a quick recap of whatever I've completed, and uh, and then we'll start from there. So uh, of all these modules, like network has the highest percentage. If you see here, it is like if you click on this one here. Uh, yeah, this one is 25-30%, right? So this uh, the network piece is like 25 to 30%. So we'll start with this one because it's the highest percent, and then let's move to the other ones. So let's start here. So we'll first look at the configure virtual networks, and we'll see what are the various topics in this. So we're talking about Azure virtual net features and components, identity features and use cases for subnets and subnetting, use cases for private and public IP address, uh, determine which resources require public IP address, which requires private IP address. Right. Let's quickly do a scan of all these topics. So let's start with the first one. We'll go through each of them, and then I'll be going through each of these sections, and then again, it's going to be like a quick review because I already have completed all this. Right. So we'll first look at the Azure Network Services and the range of components which are offered. So there is virtual network, load balancer, application gateway, traffic manager profile, virtual network gateway, virtual WAN. So there's six of them, right? So there's also a summary of each of them. So virtual network creates a logically isolated section in Microsoft Azure and securely connects it outward, right? That's the first one. And there is load balancer that distributes incoming traffic among backend virtual machine instances. And there is application gateway. Again, the keyword here is scalable layer 7 load balancer offering. Uh, this one does at layer 4, where various traffic routing rules and SSL termination for backend. Traffic manager profile, create a Microsoft Azure traffic manager profile that allows you to control the distribution of user. And then virtual network gateway, the VPN device in your Azure virtual network and used with site to site and VNet to VNet VPN. And then virtual WAN, Azure virtual WAN is a networking service that provides optimized and automated branch to branch. So these are different uh, network services. So next we talk about subnets. I think the key pieces here is all these this, conditions here, right? For example, this one is a key one. So the range for one subnet cannot overlap with other subnet IP address range within the same virtual network, right? So I think again these are the key ones. Like we should try to quickly go through these points here for each of the topics because you'll see questions in the exam specifically on these. And then we have the reserved addresses, for example, 192.168.1.0. This is just trying to identify virtual network address. 192.168.1.1 configures the default gateway. 192.168.1.1, 1.3 Azure maps these Azure DNS IP address to virtual network space. 192.168.1.255. This value supplies the virtual network broadcast address. So these five are reserved addresses uh, for this range, right? Slash 24. Yeah, and then wherever SKUs are involved, the SKUs, then it's important to know what the SKUs are. Like for example, in case of this public IP address, the SKUs selection is like this. It includes basic or standard, uh, and then the value must match the SKU of Azure load balancer with which this address is used. And then the IP address assignment, dynamic or static. So the dynamic one goes away when the VM is deallocated, uh, and then yeah, so basically if the VM is removed, the IP address goes away, but the static one stays and it can be reassigned. And then we also have a note here. If you select IPv6 for IP version, the assignment method must be dynamic. For basic SKU, the standard SKU addresses for standard SKU addresses are static for both IPv4 and v6. And the important thing to know about security of an IP address is like it's open by default, and in case of basic SKU and standard SKU, secure by default, close to inbound traffic. So that is that. Uh, so next topic is network security groups. So again, here we'll talk about when to use NSG, implement NSG rules, evaluate network security group effective rules, and advantages of application security groups. So I have like allocated 5 minutes for each topic so we can cover all of them. Right. So let's quickly go through that. So yeah, just a recap of what each of these components is very important. So in case of NSG, it has all these characteristics. NSG contains a list of security rules that allow or deny inbound or outbound network traffic. NSG can be associated with a subnet or NIC, and multiple times you can create NSG and define security rules in Azure portal, right? And then there are some default traffic rules like inbound and outbound. So if you see inbound traffic rules, these rules deny all inbound traffic except traffic from your virtual network and SSL balancers. The following image shows the default inbound security rules for a network security group in Azure portal. So as you can see here, allow VNet inbound, allow Azure load balancer inbound, but deny all inbound. So basically, if it's coming from VNet, all load balancer we allow it, everything else is denied. And in terms of the combination of all the rules you have in place and what is the effective rule, out of all those combinations. Okay, and in terms of the default rules, as you can see, when NSG is created, Azure creates the default security rule deny all inbound for a group, and similarly, uh, for in case of outbound, when an SG is created, Azure creates a default security rule allow internet outbound for a group. So this is the default behavior. And when you have NSG inbound rules for a subnet in a VM, then that takes precedence over NSG inbound rules for a NIC in the same VM. That is for inbound, and similarly for outbound, NSG outbound rules for NIC in a VM take precedence over NSG outbound rules for a subnet in same VM. So there's a nice image which will help you understand each of these pieces. But again, this is a last minute review, so yeah, there's that. The other thing is the rule priority. So the lowest possible priority value to the rule. So to ensure the particular security rule is always processed, assign the lowest possible priority value. And then the good practice is to leave like 100 as a gap between leave some gap between the rules. Next is the application security group and what does it offer as features. Next we'll move on to Azure Firewall and then all the features of it, so we can quickly go through that as part of preparation. And then it talks about the recommended approach to deploy firewall, which is a hub and spoke network topology. And then we talk about the different kind of rules you can configure for Azure, which is NAT, network, and application. And by default, firewall denies all traffic through virtual network. And then we talk about how are rules processed, the order, like for example, network rules are processed first and then application rules for network and applications. If a rule is found that allows the packet through, no remaining network or application rules are checked against the packet. After a packet is allowed, Azure Firewall checks the NAT rules or defines how to route the allowed traffic. So things to know about NAT rules. There is a protocol, there is source, destination ports, translate address, translate port. Things to know about network rules like name, protocol, source, address, destination ports. So here we don't have translate address and translate port. And then in case of application rules, name, source, address, protocol, target, FQDN is what is part of application rules. Let's move to the next topic. Configure Azure DNS. Again, the same pattern, identify use cases, verify custom domain names, implement DNS zones, delegation, and DNS record sets. So let's start with this. So here we talk about how to verify custom domain and what are the different Record types that can be used, that is MX or text. Uh, for verification purpose, MX stands for mail exchange and TXT is text record. Next is creation of Azure DNS zones. So one key point to note about DNS zone is the root or parent domain is registered at the registrar and then pointed to Azure DNS. The child domains are registered directly in Azure DNS. Then we have delegated DNS domains. To delegate your domain to Azure DNS, you need to identify the DNS name servers for your DNS zone. Next, we have DNS record sets. A DNS record set or resource record set is a collection of records in DNS zone. There are different types in it. There is type A, which is address record, and then we have other types as well. And then there is a record type called CNAME, which can contain only one record. A can contain multiple records with different set of different IP address. Uh, so there is a term called split horizon view, which basically allows a private and a public DNS zone to share the same domain name. Things to know about Azure Private DNS, like no custom DNS solution required, supports for common DNS record types such as CNAME, MX, PTR, SOA, SRV, and TXT, automatic host record management, automatic host name record management, host name resolution between VNets, uh, familiar tools and user experience, split horizon support, Azure region support. Next is virtual network peering, VNet peering. So I'll start from introduction. So when it comes to VNet peering, there are two types of peering. One is regional VNet peering, which connects Azure virtual networks that exist in the same region, and then global VNet peering, which connects Azure VNets that exist in different regions. And then we have some more details here, like you can create regional peering of virtual networks in same Azure public cloud region, or in same China cloud region, or in same Microsoft Azure government cloud region. You can create global peering of virtual networks in any Azure public cloud region or in any China cloud region. Global peering of VNets in different Azure government cloud regions is not permitted. Next, we talk about gateway transit and connectivity. So when we do VNet peering, we configure something called as Azure VPN gateway in the peered network as transit point. In this scenario, peered VNet uses the remote VPN gateway to gain access to other resources. And in terms of who can create a VNet peering, network contributor or classic network contributor role are required. And if any custom role is created, then it needs to be given necessary peering actions. So there is an important note here which says your peering isn't successfully established until both VNets in peering have a status of connected. So there are two primary status conditions. One is initial and one is connected. And then for the classic deployment model, the updating status is also used. Then we talk about how do we extend peering using user-defined routes and service chaining. Next is Azure VPN Gateway. So here we talk about the users and the things to know. So Azure VPN Gateway is a service that uses the specific type of virtual network gateway to support encrypted traffic. That's the keyword here. Again, the key thing to know here is the VPN service uses a secure pathway called a VPN tunnel for movement of your data between your device and internet. VPN tunnel is what enables your secure connection to internet. A virtual network can only have one VPN gateway. Multiple connections can be created to same VPN gateway. Uh, and then we have different configuration like site to site, point to site, VNet to VNet, and high available. When it comes to site, there are like a lot of steps involved, but there is one on-premise step which is configure VPN device, but the rest all happen in Azure. So next we talk about VPN gateway, and in that there are two gateway types. One is Azure VPN gateway or express route, and there is VPN type, which is route based or policy based. So route based VPN gateways are the most common. Typical scenarios include point to site, inter virtual network, or multiple site to site connections. Uh, and policy based support only IKEv1 protocol. And then we have these SKUs. Uh, And then we have this generation. So generation 1 supports basic and VPN1 GW1 SKUs, along with most other SKUs supported in generation 2. Generation 2 supports most SKUs available in generation 1, along with VPN GW4 and VPN GW5. So the note is you cannot change generation or SKUs across generations. So this is about creation of virtual network gateway. And then the gateway type, as I mentioned, route-based versus policy-based. And then we have this type generations, and then what is the tunnels, connections, and benchmark, right? So GW1, GW2, GW3, tunnels is 30, 30, 30 to 50, 500,000, 650 Mbps, 1 Gbps, 1 to 1.5 Gbps, generation 2, 30, 30, 100 and 100, 500,000, 5,000, 10,000, 1.25, 2.5, 5 and 10 Gbps. Next is create local network gateway. Then we talk about high availability scenarios or HA scenarios. There are two of them. One is active standby and active active. Next is about Azure Express Route and Azure Virtual WAN. So let's talk about use cases. So Express Route is a high-speed private connection to connect your on-prem network to Microsoft Cloud. So this diagram depicts it very well. So you have this on-prem customer network, and then there is partner edge, which connects to primary connection of the Azure Express route, and then this Microsoft Edge, and then you have this uh, the Office 365, all the components of Microsoft like Dynamics CRM, virtual networks, and applications. And then similarly, there's a secondary connection back to the partner edge. And then you have those inter-site connections, and there's scenarios like virtual net and point to site, develop, test, and lab environments for cloud services. And then for VMs, then you have virtual network to site, small scale production workloads, and then express route circuit, big data solutions, enterprise class, and mission critical workloads. So the key point here is Azure Virtual WAN brings together many Azure cloud connectivity services such as site-to-site VPN, user VPN, point-to-site, and then Azure Express Route into a single operational interface. There are two types of virtual VLANs. Virtual WANs, one is basic, uh, can be implemented only in site-to-site VPN scenario. And then you have standard, can be implemented with express route and user VPN as well. So next is configure network routing and endpoints. So here we talk about a route table that contains a set of rules called routes that specifies how packets should be routed in a virtual network. Next is user-defined routes, which are also called UDRs. UDRs control network traffic by defining routes that specify the next hop of the traffic flow. The next hop target can be virtual network gateway, virtual network, internet, or network virtual appliance. Next is service endpoints. A virtual network service endpoint provides the identity of your virtual network to Azure service. After service endpoints are enabled in your virtual network, you can secure Azure service resources by your virtual network by adding a virtual network rule to resources. Again, the key points here are direct traffic to Microsoft network. Use service endpoints to keep traffic on Microsoft on Azure backbone network. This approach allows you to continue auditing and monitoring outbound internet traffic for your virtual networks through forced tunneling without impacting service traffic. So with service endpoints, the VM IP addresses switch from public to private. Existing Azure Service Firewall rules that use Azure public addresses stop working after the switch. Ensure Azure Service Firewall rules allow for the switch before you can set service endpoints. You might also experience a temporary interruption in service traffic from the subnet while configuring service endpoints. Next is Azure Private Link, which keeps all traffic on a Microsoft Global Network. That's not public internet access. Uh, Private Link is global. There are no regional restrictions. Next, we talk about Azure Load Balancer uses. So there's a front end load balancer, load balancing rules and health probes, and backend virtual machine pool. Then we have a public load balancer, which is used for web tiers. And then we talk about internal load balancer, which is used mainly for database tiers. And then we have this SKUs for load balancer. That is basic and standard. Then you have this various features like backend pools, health probes, availability zones, multiple front ends, and security. So basic is open by default, closed to inbound flow unless allowed by NSG. Three-hand connections, SOAN connections, HTTP, TCP, HTTPS, HTTP, and HTTP. Not available. Zone redundant, zone front ends for inbound, outbound traffic. Inbound only, inbound, outbound. Next is backend pools. The key point here is for standard SKU, you can select virtual machines or virtual machine scale sets in a single virtual network. Your configuration can include a combination of VMs, availability sets, virtual machine scale sets. Next is health probes. Next, we talk about load balancing rules, and again, the key point here is session persistence. So you have none. Any virtual machine can handle the request. Client IP. Successive request from the same client IP address is handled by same virtual machine. Client IP and protocol. Successive request from same client IP address and protocol combination are handled by same VM. Next is configure Azure Application Gateway. Start with introduction. Here we have benefits like application layer routing, round robin load balancing, session stickiness, support protocols, HTTP, HTTPS, HTTP/2 web server protocols, firewall protection, encryption, load auto scaling. There are two types of route primary methods like path-based routing, multi-site routing. Next, we talk about network IP addressing and integration. So we have covered the configure manage virtual networks for Azure admins. So let's move to the next one. Let's do the storage for. So let's look at manage storage. So first we talk about storage accounts. So this accounts to like 15 to 20% of the exam. And there are different types of like data that we have when we talk about storage. Like one is VM data, which includes disks and files, unstructured data, which includes unstructured data, which is a non-relational data, and structured data, which is often in database tables with rows, columns, and keys. The tables are an auto-scaling NoSQL store. And then we have the storage account tiers, standard and premium. Standard are backed by magnetic HDD, and premium are backed by solid-state drives. You cannot convert a standard tier storage account to premium. You must create a new storage account, then copy the data. Then we talk about storage services, blob storage or containers, files, queue, and table storage. Blob, massively scalable objects, so for text and binary file share for cloud or on-premise deployment. Messaging store and NoSQL store. Here are some examples. We use blob storage for storing files for distributed access, streaming videos and audios, storing data for backup and restore, disaster recovery, archiving, for analysis on-prem or Azure hosted. You can access Azure Blob Storage by using NFS protocol, also via HTTP, HTTPS. Next is Azure Files. Uh, Scenarios are on-prem application use file shares, configuration files, diagnostic logs. And then next is queue storage is mainly for queue management. It can be up to 64 KB in size. Table storage is as part of Azure Cosmos DB, fully managed NoSQL database service. Next, we have storage types: standard, general purpose V2, premium block blobs, premium file shares, premium page blobs. So the support services in standard blob storage, including data lake storage, queue storage, table storage, and Azure files, blob storage, including data lake storage, premium blobs. Premium files and premium page blobs are only Azure files and page blobs only. And the recommended use cases, standard storage account for most scenarios, including blobs, file shares, queues, tables, and disks, and then premium storage account for block blobs and append blobs, recommended for applicants with high transaction rates and that require low storage latency. Premium storage account for file shares only, recommended for enterprise or high performance scale applications. Uh, and then premium high performance storage account for page blobs only, for storing index-based and sparse data structures such as operating systems, data disks for VMs and databases. All storage account types are encrypted by using storage service encryption for data at rest. And then we have a replication strategy. So we have LRS, ZRS, GRS, and GZRS. And then in GRS we have RAGRS. And then you have RAGZRS. So what are the scenarios like that will happen? I mean, where each of this will come into play. If node and data center is unavailable, then LRS, all these will come into play. Entire DC is unavailable, then zone, ZRS, GRS, RAGRS, uh, GZRS, and RAGZRS. Region-wide outage, then zone doesn't come into play, then all these, and then read access during region-wide outage, RAGRS, RAGZRS. Support storage accounts, GPv1, v2, blob, GPv2, GPv. Next is how do you upload blobs. So you have blobs, append page. After you create a blob, you cannot change its type. So we have different tools like AZ copy, Azure Data Box, and Azure Import Export. AZ copy is a command line tool. Azure Data Box disk is something which you get from Azure, like a equipment basically. And then Azure Import Export is a service that helps you export large amount of data. Uh, and again, that involves shipping, but you give the disks basically. Next is how do you configure Azure Storage Security. So we have shared access signature, access keys, and Active Directory authentication. So we have this different authorization security. One is Active Directory, and then you have this shared key. Shared key relies on your Azure Storage account access keys. The string is passed on request in authorization header. Then you have shared access signature. Is a dedicated access to a particular access in your Azure Storage account with specific permissions and for a specified time interval. Anonymous access to container blobs. You can optionally make blob content public. And when it comes to SAS, it is at account level or service level. Uh, then we have different parameters for SAS, like for example, SV stands for storage version, and then S stands for storage service, start time, expiry time, resource, permissions, IP range, protocol. SPR stands for protocol, and signature is SIG. Then the next is your encryption. Then you have this configuration for encryption. Then you have custom managed keys, encryption type and encryption key, right? Then you have just best practices. Like basically we talk about when to use SaaS and when to use other types. Next is Azure Files and Azure File Sync. The key point about Azure Files is applications that run in Azure virtual machines or cloud services can mount an Azure file storage share to access the file data. This process is similar to how a desktop application mounts a typical SMB share. So the scenarios are lift and shift, global access, replacement and supplement options. Then there's Azure File Sync agent, shared applications, diagnostic data, and tools and utilities. So like again, we have this various comparison. Azure Files, blob storage, and disks, page blobs. So files in Azure File Share are true directory objects. Blob is a flat structure. Page blob is disks. Page blob data is exclusive to single VM. Blob data is in Azure. Blob storage is accessible through container. Data in Azure Files is accessible through file shares across multiple VMs. Is ideal for lift. Azure File is ideal for lift and shift to cloud or use native file system APIs. And is a good option when you want to store development and debugging tools that need to be accessed from many VMs. This is used for its support of streaming and random access scenarios. When you want to be able to access application data anywhere, ideal for application and frequent random rated operations. This is a good option when you want to store relation data, operating systems, and data disks in VMs and databases. Next is how do you manage it? Then there is open port 445. Use this port to communicate. So you have to keep it open, enable secure transfer. And then we talk about how do you mount Azure File Share on Linux. So next we talk about file sync and how do you deploy it. So first we deploy storage sync service, prepare Windows servers, install Azure File Sync agent, and register Windows servers. Next we talk about how do you configure Azure storage with tools. First we talk about Storage Explorer. Next we talk about Azure import jobs, and then what are the steps involved. So import data with Azure import export. You, as a customer, you'll prepare disks, create a job, and ship it. Azure Data Center receives disk, transfers data, package disks, ship it back. Then you receive disks, view data, and Azure storage. So basically, we're trying to uh, import secure large amount of data to Azure blob storage or Azure files. So there are steps involved. Uh, and then to create an import job, you have to follow the steps. Identify a computer used to perform the data copy, attach the physical disk unit to ship to Microsoft. Install WA import export tools on our disks. We'll take a closer look at that next unit. Run the tool to copy data to onto disks. Encrypt disk drives with BitLocker. Generate journal files to document data transfer. In Azure portal, create an import job. Provide the following information: storage account, return address, carry your shipment carrier account number, data center address for of the Azure region that hosts the Azure storage account. Then you ship the required number of disks to the Azure data center that hosts storage account, note the shipment tracker number. Update the import job to include shipment tracker number. After this data center, the staff completes the following tasks. Data on the provider disk is copied to specific storage account. The ships are back to you. Shipped back to you. So here the key thing is WA import export tool that is used for when you want to import data. And then you have the export option where if you want to export data from Azure, lets your hybrid users access both on-prem and cloud resources. This edition supports advanced administration like dynamic groups, self-service group management, cloud write-back capabilities. P1 also includes anti-manager on-prem and access management suite. This extra feature in P1 allows self-service password reset for your on-prem users. This is a keyword here, SSPR for on-prem users. And here the next one is P2 offers identity protection to help provide risk-based conditional access to your apps and critical company data. Risk-based conditional access is the keyword here. It also includes to help discover, restrict, monitor, administrators and their access to resources and to provide just-in-time access when needed. So there are two keywords here. One is risk-based conditional access and just-in-time access. Next, we talk about Azure Active Directory join. Next, we talk about how do we implement uh, self-service password reset. So the first requires an Azure AD account with global administrator privilege to manage SSR options. This account can always reset their own passwords and no matter what options are configured. SSPR uses security group to limit users who have SSR privileges. All user accounts in your organization must have a valid license to use SSPR. So next we talk about users and groups. So we talk about administrative units. So create a role that has administrative permissions for only Azure AD users in engineering department administrative unit. Create an administrative unit for engineering department, populate administrative with only the engineering department student staff and resources, and the engineering IT department team to role along with this scope. Next we talk about how do you configure subscriptions. Next we talk about implementing Microsoft cost management. Next we talk about apply resource tagging. You can apply tags to resources to logically organize them by categories. Tags are useful for sorting, searching, managing, and doing analysis of your resources. Then we talk about applying cost savings. So you have reservations, Azure hybrid benefits, Azure credits, regions, budgets, pricing calculator. Next we talk about configuring Azure policy. First we talk about creating management groups. So here we have a diagram that talks about how to organize subscriptions under different management groups. So there is a root management group, and then we have different departments management group. Under that we have all the subscriptions, and then you have this hierarchy here. So next we talk about policy definitions. For example, allow virtual machine SKUs, allow locations, configure Azure device update for IoT hub accounts to disable public network access, and so on. So next we talk about role-based access control. So here are the concepts. One is security principle, role definition, scope, and assignment. Security principle, an object that represents something that requests access to resources. User group, service principle, and managed identity. Role definitions, set of permissions that allowed operations. Example, Azure Armor comes with built-in role definitions, but you can also create your own custom role definitions. Reader, contributor, owner, user, access administrator, scope, the boundary for requested level of access, how much access is granted, root, management group, subscription, resource group, and resource. And finally, the assignment. Assignment touches the role definition to security principle, to particular scope, assign the user access administration role to admin group, scope to management group, assign the contributor role to a user scope to a subscription. So next we have this assignments, assignable scopes, which can be management groups, subscription resource groups, or resources. Then we have role permissions. So use actions and no actions permissions together to grant and deny exact privileges for each role. The action permissions can provide the breadth of access, and no action permissions can narrow the access. Then we have this role name, description, action permissions, no action permissions. Owner, allow all action permissions, star, not applicable. Contributor, allow all actions except write or delete role assignment. For example, you have star here, then like no action, Microsoft authorize slash delete, Microsoft authorization slash write, elevate access, and then reader, allow all read actions, not applicable, so slash no read. And then there is role scope. Scope a role as available for assignment in two subscriptions, slash subscription 1, subscription 2. Scope a role as assignment for assignment only in network security group subscription slash resource group slash network. And scope role for all requesters slash. Then we talk about some fundamental Azure RBAC roles. Owner, the owner has full access to all resources, including right to delegate access to others. Service administrator, co-administrator roles are assigned the owner role at the subscription scope. Contributor role can create, manage all types of resources. The role can't grant access to others. Reader reader role can view all existing resources. User access administrator role can manage user access to Azure resources. So that's about configure RBAC. Let's move to the next topic. Create Azure users and groups in Active Directory. So let's start. So add users, manage apps and resources access by using Active Directory groups. Give guest user access to Azure Active Directory business to business. So we have some commands on how to, you know, if a user has a user administrator or global administrator role, you can create a user in Azure AD by using either Azure Portal, CLI, or PowerShell. In PowerShell, run the command let new Azure AD user. In Azure CLI, use AZ space AD space user space create. Next, we have some CLI commands like how to create a user and then command from Azure PowerShell. You can bulk create as well. So you have this import CSV and then you have this validations in place. Like, and then if in order to delete users, so you run the command remove -az80 user, az80 user delete. So when you delete a user, the account remains in suspended state for 30 days. During the 30 days, the user can be restored. Next is allow users to reset the password with Azure Active Directory self-service password reset. So what are different ways to authenticate? On as mobile app notification. Then you have this mobile app code, email, mobile phone, other phone security operations. And then each of them have a way to register and how to authenticate for password reset. Next is how do you deploy SSR? You can deploy SSPR with password write back by using Azure AD Connect or Cloud Sync. Depending on the needs of users, each option can be deployed side by side in different domains to target different set of users. This helps existing users sometimes write back password changes while adding an option for use in disconnected domains because of the company merger or split. Users from an existing on-prem domain can use uh, Azure AD Connect while new users from Azure can use Cloud Sync and another domain. Cloud Sync can also provide high availability because it doesn't rely on single instance of Azure Connect and all that. So, okay. So basically the key point here is SSPR with the password write back by using Azure AD Connect or Cloud Sync. So next we talk about deploy and manage Azure compute resources. So we'll start with configure virtual machines, introduction. This is a 20-25% exam share. Then we have different size classification for Azure VMs like general purpose, compute-based, compute optimized, memory optimized, storage optimized, GPU and high performance computes. So uh, the scenarios are general purposes for test development, low medium traffic web servers, compute optimized for network appliances, batch process applicant servers, memory optimized is for basically high CPU to memory ratio and high memory to CPU ratio. Database servers, medium to large caches, in-memory analytics, storage optimized, big data, SQL, NoSQL, data warehousing, GPU, model training, inferring the deep learning, high performance workloads that require fast performance, high traffic. So be cautious when restarting production instances. Restarting might require a restart and can also be outage. Next is storage. There are like different types of storage. One is operating system disk, temporary disk, and data disk. Don't store data on temporary disk. This disk provides temporary storage for applicants and process and is intended only to store data like pages and swap files. Then you have Azure Premium Storage, multiple storage disks, managed disks. Managers are required for single instance virtual machine SLA. Consider migrating to premium storage. And then how do you create a virtual machine? And how do you connect it? There are different ways of doing it. One is you can use RDP client or SSH client or Azure Bastion uh, method. So, so Azure Bastion provides a secure RDP SSH connectivity to all VMs in your virtual network in which it's provisioned. Azure Bastion protects your virtual machines from exposing RDP SSH ports to outer world while it still provides secure access. Azure Bastion lets you connect to virtual machine directly from Azure network. You aren't a client, you don't run a piece of software. You don't need any of them. Next is VM availability, traction. First, we talk about availability sets. And here are some things to know. All VMs in availability set should perform identical set of functionalities. All VMs in availability set should have the same software installed. All Azure ensures that VMs in availability set run across multiple physical servers, computer rack storage, and network switches. If hardware or Azure software failure occurs, only a subset of VMs in availability set are affected. Your application stays up and continues to be available to customers. You can create virtual machine and availability set at the same time. A VM can only be added to one availability set. And when a VM is created, to change the availability set for a virtual, you need to delete and recreate a VM. You can build availability sets by using Azure Portal, ARM, scripting, and so on. Next is update and fault domains. Azure VM scale sets implements two node concepts to help Azure maintain high availability, fault tolerance when deploying and upgrading applications, update domains and fault domains. So by default, there are 5 update domains, and you can configure up to 20 update domains. Uh, then you have this fault domains. Fault domain defines a group of VMs that share common set of hardware that share a single point of failure. Example is server rack serviced by a set of power and network switches. Two fault domains work together to mitigate against hardware failures, network outages, power interruptions. So there's fault domain. There is this availability set. So basically, you put one VM from each in the availability set, so there's always availability. And review availability zones. Availability zones are high availability offering that protects your applications and data center failures. Data center failures and availability zone is a natural region is a combination of fault domain and update domain. Availability zones are unique physical locations within Azure region. Each zone is made up of one or more data centers that can be with independent power cooling and networking. To ensure resilience, there is a minimum of 3 separate zones in all enabled regions. The physical separation of availability zones in the region protects applications and data from data center failures. Zone redundant service replicates your applications and data across availability zones to protect against single point of failure. So there are 2 categories. One is zone services, zone redundant services. Azure Zone Services pin each resource to a specific zone. For Azure services that are zone redundant, the platform replicates automatically across all zones. The examples: Azure VMs managed disk standard IP addresses, Azure storage that's zone redundant, Azure SQL database. And there is vertical and horizontal scaling. Uh, Vertical scaling, scale up or scale down, involves increasing or decreasing VM size based on the workload. Scale up means making the VM more powerful. Scale down is less powerful. Things to know about horizontal scaling: scale out and scale in. Uh, the scale out means increase in the virtual machine count, and scale in means decrease in virtual machine count. So up and down are vertical, and in out are horizontal. Virtual machine scale sets are Azure computers that you can use to deploy and manage set of identical virtual machines. When you implement virtual machine scale set and configure all VMs in the same way, you gain true auto scaling. So VM machine scales will automatically increase the number of your virtual machines instances as application demand increases and reduce the cost of machine instances as demand increases. So VM skill sets support the use of Azure Load Balancer for basic layer 4 and Azure Applicant Gateway for more advanced layer 7 traffic distribution and SSL termination. VM skill set support up to 1,000 virtual machine instances. You can create, upload your own custom images. There's a limit of 600 virtual machine instances. In terms of enable scaling beyond 100 instances, if you select yes or no. If you select yes, your implementation can span multiple placement groups with capacity of up to 1,000. Select yes also changes the availability characters of your implementation. Spreading algorithm, Microsoft recommends allocating maximum spreading for implementation. Implement autoscale, so min and max. Things to consider adjust capacity, scale out, scale in, schedule elements, and overhead. Then you have configure autoscale, instance count, minimum, maximum, CPU, scale out, CPU threshold duration minutes, scale in, 25, and scale in. So scale in policy, default, newest VM, oldest VM. So balanced across availability zones and fault domains, and delete the VM with highest instance ID. Balance across availability zones, delete VM with newest creator ID. Balance across availability zones, and delete oldest VM. So that's about the configure VM. Then we have configure virtual machine extensions. They mainly used to do post-deployment configuration tasks. You can manage VM extension using CLI, PowerShell, or ARM templates. Can be bundled into new VM deployment or run against an existing system. There are already available ones, like for example, custom script execution in PowerShell desired state. For the custom script execution, you install a custom script extension from Azure portal by accessing your virtual machine extensions page. And after the custom script extension is created for your virtual machine, you provide a partial script file with commands to execute on the machine. You can also provide specify optional arguments. So for example, you can also use the PowerShell set AZ104 custom script extension command to run scripts with custom script extensions. The command requires URI for the script in the blob container. So you have set AZ104 custom script extension file URI, run PowerShell.exe, VM name, source group name, location. So there is a timer setting of 90 minutes. If your deployment takes longer than 90 minutes, your task is marked as timeout. Dependencies, failure events, sensitive data, account keys, for example. And there is desired state configuration. You can use desired state configuration when custom script extensions don't satisfy the application requirements for your automation. Desired state configurations centers around creating specific configuration by your scripts. So it has following blocks like configuration, node block, one or more resource blocks. Uh, so this is an example. So there's a configuration block which has a named, and there is one node block that targets a computer resource named localhost, and then there is one resource block that specifies web server feature, Windows feature for iOS. The ensure value indicates a feature is present. So next we talk about configuring Azure App Service plans. So introduction, scale a web application enables remain responsive during periods of high demand. So implement Azure App Service plans. So App Service plan has three settings: region, number of VMs, size of VMs. Next, we talk about app service plan pricing tiers. Uh, so usage, web, mobile, or API applications, disk space, auto scale deployment slots, maximum instances. So they have free, standard, basics, free, shared, basic, standard, premium, isolated. So deployment slots are 20, 20 for the last two, and then 5, and then slots are not applicable for shared and basic and free. Autoscale is supported everywhere, and then disk space is 1 TB, maximum instance up to 100, and isolated 30 and 10, the remaining ones. Isolated is for high performance secure isolation and enhanced scale performance, production workloads. This was standard. Scale up and scale out options are two methods for scaling your Azure service plan. Scale up and scale out. Uh, so scale up method increases the amount of CPU, like it's like vertical, and scale out is horizontal. So the amount of CPU memory and disk space. Scaling up gives you extra features like dedicated VMs, custom domains and certificates and staging slots, etc. You scale up by changing the pricing tier of your Azure App Service plan when your application is placed. Scale out method increases the number of VMs. You can scale up to as many as 30 instances depending on service plan pricing tier. Uh, and then so you have two options. One is metric based and time zone based. Metric based is based on a specific metric, and this time based, not time zone, time based, like when you want this to be applicable. Next is configure Azure App Service, the use cases for that. So the benefits, multi-language and framework, DevOps optimization, global scale with high availability, connects to SaaS platforms, security and compliance, application templates, Visual Studio integration, API and mobile features, serverless code. Uh, you can create, you can use the web apps, mobile apps, or API apps, features of apps, and create your own apps in Azure portal. Uh, so you have the name, you have the publish, and runtime stack, operating system region, post creation. There are other settings you have to do, like always on ARR affinity, and then connection strings. And then this, how do you do the continuous deployment and integration? And there is deployment slots when you deploy your web app on Linux, mobile backend or API app to Azure App Service. You can use separate deployment slots and stuff deploying to default production slots. So there is deployment slots are live apps that have their own host names. Deployment slots are available in standard, premium, and isolated app tiers. Your app needs to be running in one of these tiers to use deployment slots. Uh, so consider validation, consider reduced runtime, consider restraint last none. And then consider autoswap. Autoswap streamlines Azure DevOps scenarios where you want to deploy your code continuously with zero code starts and zero downtime for app customers. Then add deployment slots are configured in Azure portal. You can swap your app content and configuration elements between deployment slots, including production slot. Deployment slot settings fall in three categories: slot specific, app settings, and connection strings. Continuous deployment, Azure App Service authentication settings. So swap settings is slot specific settings. Swap settings, you have app connection handle settings, public certificates, web job content, hybrid connections, service endpoints, Azure Content Delivery Network, and then path mapping. Then you have slot specific, custom domain names, non-public certificates, scale settings, always on, IP restrictions, and diagnostics settings, cross origin resource sharing, virtual network integration, manage identity settings, and with suffix extension version. The next is how do you secure your app service app, built-in authentication. Then you have logging and tracing. Then you have creating custom domain names. Next is how do you backup and restore your app. And using Azure Application Insights. So you have your web apps, your web service, and then your SQL external service and background services, and then you have your application insights, you have alerts, Power BI, Visual Studio, REST API, and continuous support. Next, you have configure Azure container instances. So let's start with introduction, compare containers to virtual machines. So next we talk about Azure Kubernetes service. So there are different Kubernetes service types from Azure. One is clustered IP, create an internal IP address for use within Azure Kubernetes service cluster, implement internal applications that support other workloads within the cluster. And there is node port, create a port mapping of the underlying node, allows direct access to the application within node IP address and port. Load balancer, create Azure load balancer services and configure external IP address and connect the requested ports to load balancer backend pool. Allows customer traffic to reach application by creating load balancer rules or desired ports. External name, create a specific DNS entry, supports easier application access. The next is the storage aspect of this Kubernetes service. So you have, so next we talk about persistent volume. Volumes are defined and created as part of the pod lifecycle and exist only until the pod is deleted. Pods often expect the storage to remain in the pod if the pod is rescheduled or on a different host during the maintenance event, especially in the stateful states configuration. A persistent volume is storage resource that's created and managed by Kubernetes API and that can exist beyond the lifetime of individual pod. So you can use Azure Disk or Azure Files to provide persistent volume. The choice whether to use disk or files is often determined by need for concurrent access to data or the performance tier. A persistent volume can be statically created by cluster administrator or dynamically created by Kubernetes API server. If pod is scheduled and requests storage that's not currently available, Kubernetes can create underlying Azure disks or file storage. Kubernetes also attaches storage volume to the pod. Dynamic provision uses storage class type to identify what kind of storage type needs to be created. So you have storage class type like default, then you have managed premium, Azure File premium, and then you have this reclaim policy action, ensures underlying Azure disk is deleted after when the persistent volume that uses the disk is deleted, ensures underlying disk is deleted when the persistent volume disk is deleted. Uh, yeah, all have the similar principle basically. If no storage class type is specified for persistent volume, the default type is used. Next is configure Azure Kubernetes server scaling. Uh, so they have scale out and scale in options. So manual scale poles are no scale pods are nodes, automatic scale pods, automatic scale clusters. There is support for this. Automatically scale pods is available for 1.8 or later, 1.10 or later automatic scale clusters. So some things to consider using horizontal auto scaling, number of pods, scaling metrics, cooldown for scaling events, and then consider tuning cooldown values. So there's a to more quickly increase the number of replicas in use, reduce the horizontal pod autoscaler upscale delay value by creating your HPA definition by using Azure CLI kubectl or kubectl tool, kubectl. Next, we talk about rapid burst scaling. Next is how do you manage virtual machines used with Azure CLI. So we talk about various commands which are involved. So this is the Azure CLI script, AZ104 create, then you provide resource group, location name, image, admin user, and then generate SH keys and verbose, and then you get output like this. So you have FQDNs, ID, location, MAC address, power state, private IP address, public IP address, users group, and zones. So next we talk about how do you query system and runtime information about VM. So there's a command called AZ list that will give you a list of all the VMs defined in the subscription. You can also filter out based on specific resource group. And then you have table option, then you can get the IP address and then get VM details. You can add filters with JMES path, and then filter your Azure CLI queries. And then you can have the output type. So next we move to the next topic, which is start stop your VM. So for that, AZ VM stop, and then you give the name in the resource group, and then AZ get instance view to get name in the resource group query, and then AZ VM start, and then the restart. There's an await also. And then you have the next unit, which is install a software. So AZ VM list IP address, and then you can search that VM, and then you can install any software like Nginx, for example, and then you retrieve the default page, all of that. And then if you want to do any port opening, then you have to say AZVM port, and then you, yeah, do other stuff. So next we have create a Windows virtual machine in Azure. So let's open that. So here we talk about creating an Azure VM. What are the resources used, choosing the VM image, size of the VM, and then you have different sizes like depending on the computing, like general use computing, you have V, DSV3, DSV2, DSV2, heavy computational tasks, FSV2, large, memory usage, ESV, DSV2, data storage and processing, LS, then you have heavy graphic, NV, high performance edge, you have storage options, and then you have this operating disk, temporary disk, and then you have managed OS and managed disks. Network communication, and then you have the network configuration for that, and then RDP, how do you connect to the VM? Uh, and then how do you configure VM settings, network settings, open ports, using network security group rules. So SMTP is a special case depending on your subscription level. When your account was created, outbound SMTP traffic may be blocked. You can request it, request to remove this business justification. So that's about your VM. It's about your Windows virtual machine in Azure, that piece there. So next we talk about how host a web application with app service and the different methods. So for manual deployment, you have all this like git and then az web app up and then zip deploy, which is az web app deployment source config -zip. And then you have this var deploy, which is to deploy the var files. You have kudu HTTP API located at this location. And then you have Visual Studio and FTP. And then you have protect your VM settings with Azure automatic automation state configuration. So let's talk about this. What is Azure automation state configuration? This is to ensure that VMs in the cluster area are in the consistent state with same software installed and same configuration. Review the declarative model of PowerShell desired state configuration and explore its benefits. Why use Azure Automatic State Configuration? With PowerShell DSC declarative management platform, the Azure Automation State configuration used to configure deploy and control systems. And so the idea is like you maintain the desired state. Then we have LCM, which is Local Configuration Manager, is a component of Windows Management Framework. Then you have push and pull architecture in the DSC. The next is a PowerShell command for DSC resources. So you have get -DSC resource, select name, module, and properties. You have configuration, node, and Windows feature, three blocks. And the last topic is monitor and backup Azure resources. So let's start with this configure file and folder backups. And this is about 10 to 50% of your exam. And then we have this Azure Recovery Service Vault backup options. With Azure subscription, you can create up to 500 recovery services vaults per region. Then we have three storage replications: geo redundant, local redundant, and zone redundant. Then you have Microsoft Azure Recovery Services Agent. So these are different steps involved in configuring a backup of files and folders using Azure Mars Agent. Next, we talk about virtual machine backups. So first we have Azure Backup, then you have Azure Site Recovery, Azure Managed Disk Snapshot, Azure Managed Disk Image, and these are the different options available. So next we talk about implementing soft delete for your virtual machines. So the soft delete for virtual machines protects backup from virtual machines from unintended deletion even after the backups are deleted. They're preserved in soft delete state for 14 more days. Next, we talk about Azure Site Recovery. So there are two regions. So replicate Azure virtual machines from one region to another, replicate on-prem VMs to Azure, replicate AWS instance to Azure, replicate on-prem VMs to secondary site. So things to consider: consider management reduces cost and complexity, replication resilience, configure replication, snapshot recovery points, failure and easy backup integration. Next, we got to talk about configure Azure Monitor. So the key capabilities are monitor and visualize metrics, query and analyze logs, set up alerts and actions. Now, in terms of monitoring and data tiers, you have application, operating system, services used by application, the platform that supports your application. All these are your tiers. Now, in terms of activity logs, for application, you have application logs, diagnostic logs, and then guest OS, host virtual machine. Then you have activity logs for Azure infrastructure. In case of resources, you have diagnostic logs, and again, you have for non-compute resources, you have only Azure infrastructure activity logs. Then in terms of how do you query the activity log, you can do it based on subscription, time span, event severity, resource group, resource name, resource type, operation name, event initiated by, and then you have event category like administrative, service health, resource health, alert, auto scale, recommendation, security, policy, all those. Next, we have configure Azure alerts. An alert consists of alert rules that combine settings and conditions you want to monitor. For example, resources to monitor, signals or telemetry to gather from resources, conditions to match. So this is the alert Azure alert process. You have alert rules. Then when the conditions are met, you fire alerts. Then you have alert processing rule, and then there is an action group, which includes notifications and actions, which will basically trigger the actions. So you have Azure resources, where you have Azure monitor metrics and logs that will go into telemetry evaluation, where you have alert rules, where you have scope, resources, signals, and conditions. If all three are met, then we create alert processing rule, like for example, suppress or add actions and then action group. Then you have actions. Next is monitor alerts. So there are different types of alerts like metric alerts, log alerts, activity log, events, smart detection alerts. And then you have alert states like new, acknowledged, and closed. Uh, Only the initial new state for an alert is set by system. All other state changes must be made by you as administrator. There are two types of alerts, stateless and stateful. Stateless alerts trigger each time your alertful conditions match your data. Stateless alert trigger when your alertful condition matches your data and same alert doesn't exist. And then you have action groups, include how to configure notifications and define actions. Multiple alerts can use same action group or different action groups depending on the user requirements. So notifications specify how to notify users when your action group triggers. Actions specify how to invoke your different actions when your action group triggers. For example, your action type can be automation runbook, Azure function ITSM, logical apps like your webhook and webhook. Next is configure log analytics. Here we talk about KQL, Gusto query language, where you can create simple and complex queries with KQL, including search and sort by value, time, property, state, and more. Join data from multiple tables, aggregate large sets of data, perform intricate operations with minimal code. Then you have log analytics workspace. Next is configure Azure Network Watcher. So it has all these features like IP4 verify, next hop, VPN troubleshoot, uh, and NSG diagnostics connection troubleshoot. To use Network Watcher, you must be an owner, contributor, or a contributor, or a custom role. So in terms of next hop type, it can be internet, virtual appliance, virtual network gateway, virtual network peering, virtual network service endpoint, or Microsoft Edge, or so on, or none, right? Uh, if the next hop type is none, there may be a valid system route to destination IP address, but no next hop exists to route the traffic to the target. Next is visualize network topology. Uh, Azure Network Watcher topology tool generates a visual diagram of users and virtual network. The graphical display shows users and network, their interconnections, and their relationships with each other. You can use subnets, virtual machine network interface, public IP address, and NSGs to generate topology and Azure Network Watcher instance in the same region as the virtual network. Next is improve incident response with alerting on Azure. So explore different alert types that Azure Monitor supports. So we have metric, activity log, log alerts. Composition of an alert role, resource, condition, action, alert details, alert. The severity type can be 0 through 4. Critical error warning, information verbose. Scope of alert rules, metric values, log search queries, activity log events, health of underlying Azure platform, test for website connectivity. Next, use metric alerts for alerts about performance issues in your environment. You can use metric alerts to achieve regular threshold monitor of your resources. Composition of metric alert uh, type of. So use static threshold metric alerts, use dynamic threshold metric alerts. Look back period defines how many periods you need to be evaluated, understanding dimensions, scale metric alerts. Next, we have log alerts to alert on event. When you use log alerts, behave in a slightly different behavior than other mechanisms. So every log alert has a shared search role, log query, time period, frequency threshold, metric measurement like aggregate function group, uh, interval threshold, stateless nature of log alerts. Next, we have analyze Azure infrastructure by using Azure motor logs. Feature of Azure motor logs. So this is the log analytics workspace where you can run the commands and you get the output. And then in metrics, I have here analyzing logs by using KQL. So you have these queries for KQL, and then you have the different, again, UCF logs. And then finally we have for the last topic, which is the monitor performance of VMs by using Azure Monitor VM Insights. So Azure Monitor logs collects and organizes log data generated for Azure resources. What is the relationship between all the native monitoring tools like application, guest OS, Azure subscriptions, and tenant? This data is collected from all these sources, and we want to draw insights, visualize, analyze, respond, and integrate. Then you have to plan log analytics workspace, how you want to present the data. Access mode, access control mode, and table level are back. So access mode, there are two options. Workspace context provides access to all logs in the workspace where the permission is assigned, queries are scoped to all data in the tables. Resource context provides access to view logs for resources in all the tables you have access to. Requires workspace permissions means a user would have access to all data in a table, and which doesn't allow granular role-based access. Users use resource or workspace permissions allows granular RBAC. And then you have table level RBAC. This feature allows your administrator to define what specific data types are accessible to set of users. The best strategy is to limit the number of number of workspaces required for daily operations. So the following tables list each agent like Azure Monitor agent, Log Analytics agent, Azure Diagnostics extension, dependency agent. Then you have set up Log Analytics workspace. And in this, you will see in monitoring insights, you can see a map against the VM where you can see the processes that are running and then the ports and the clients and so on that are interacting with the VM, all of that. So this is part of monitoring insights for a given VM. And then you can also look at insights metrics for that VM. You can see the row in the table, right? And build log queries using KQL. There are by default case sensitive, use pipe character delimit operators, and then yeah, then you have this build log queries. Uh, you have the option to build it in the query pair. You have already pre-built queries you can use, and then you can add that to the dashboard. That's the last topic. So that covers all the preparation we want to do for the exam. Thank you for watching.